Okay, guys, this is the second time I'm recording this one. My computer's taking a bit of strain with the memory that it needs, but let's try again. Okay, so now this one we're also going to be acknowledging it's in the form y equals a times b to the x minus c. Oops. Plus d. Okay, we need to rearrange it so that it is in that form. So we have y equals negative 4 times 2 to the negative x plus 1. And interestingly, we have a negative over here and a negative over here. So immediately you should be thinking there are reflections involved. So A, that's going to disappear, A equals negative 4. So the graph is dilated by a factor of 4 from the x-axis and reflected about the x-axis. All right, now b value is negative 1, so b is negative 1. There is no dilation, so we're always comparing it to the base graph of y equals 10 to the x, so there's no dilation, but our graph is reflected about the y-axis. Now you need to close your eyes and imagine what this graph is going to look like, because it has now been flipped down and then flipped back to front. Okay, and when we look at our d value, it has been shifted up. So this graph has moved quite a lot. Okay, look at our c value is equal to 0. So we have no horizontal shift. And our d value is equal to 1. So our graph has shifted 1 unit up. Now, when you look at that with that shift, you need to automatically say to yourself, I need to acknowledge where my asymptote is. So my horizontal asymptote is going to be at y equals 1. That vertical shift tells you where your asymptote is. All right. Now, for this graph, once you closed your eyes and you imagined what was going to happen with it, you have a chance of having an x and a y intercept, and because of the shift up, it will have an x intercept as well, which means you're not going to have to try and find another point that keeps your life easy. You can just use your intercepts. Okay, so let's start with our y-intercept. Y-intercept happens when x equals 0. So we have y equals 1, take 4 times 2 to the 0. And that 2 to the 0 is going to be 1, so we get that y equals negative 3. So my y-intercept will be at 0, negative 3. My x-intercept happens when y equals 0, and that means I have that 0 equals 1, take 4 times 2 to the negative x. And these are one of the reasons we made you practice all of those exponential equations, because now we have that negative 1 is negative 4 times 2 to the negative x. A quarter is 2 to the negative x. And 4 to the negative 1 is 2 to the negative x. Remember, your bases have to be the same before you can equate your indices. So 2 to the negative 2 is 2 to the negative x, and therefore negative x is negative 2, or x equals 2. So now I have my x-intercept at 2, 0. All right. I'm going to write the word range down, but I think it's easier to interpret the range after you've actually drawn the graph. I'll just write range here and we'll come back to it. Okay. And let's draw the graph. I'm going to insert my asymptote over here. It looks like inserting the asymptote really upsets this thing. Gets all confused. Did this to me the last time, but hopefully this time it won't. I'm not going to try and do anything funny with that asymptote. I'm going to just carry on drawing and just see how we go. All right. That's going to be my point 1, 2, 3, 4. Remember, my y equals 1 is my asymptote. And on my x-intercept, remember my y-intercept was at negative 3, so I need to go at least down to negative 3, and on my x-intercept I'm going to have to go across to 2. And I need to mark those. So here I've got 0, negative 3, and here I have 2, 0. All right, I've marked my asymptote. I have marked my 2 points on my graph. Now I'm going to need to draw a smooth curve through those points, making sure that I have an exponential shape. And you do not cross your asymptote. And then we label our graph. Y equals, what was it? 1 minus 4 times 2 to the negative x.